Okay, welcome back, and now let's talk about the area of a circle. The formula, the most common formula that we're given for an area of a circle is this formula here, pi times r squared, or just pi r squared, okay? But I thought pi r round, not squared, Mr. C. No, I'm just kidding. So pi r squared, okay? So this is the formula, and now what if we're given diameter, like for example in this example here. Well, we could take half of this, right, and then stick it in here, or we could use another formula that is based off of diameter. So the way you get that formula is just replace r with an equivalent expression for diameter, right? Remember, r is equal to half the diameter. So we could just go ahead and write this as pi times, and just replace r with d over 2 squared, right? And so then what happens? This is going to be simplified to what? Pi, and then this is going to become d squared over 4, right? Because we could distribute the exponent to the top and the bottom. And so our final answer then becomes what? Our final formula, rather, is just going to be pi d squared over 4, okay? Or 1/4 pi d squared, whichever one you want to use, okay? But again, typically this is the most common one that you'll see in textbooks, but hey, this one will also work if you're given the diameter. For example, in this case here, we are given the diameter of 8.25 inches. And so if I wanted to find the area of the circle with that diameter, then I would just use that one. So it's 1/4 pi times 8.25 squared. Okay, and then I could just put this in my calculator and plug and chug, right? So, what do I get? I get approximately 53.456 inches squared. Okay, or just round it to 53.5. So 53.5 square inches is what we get. Now let's do another one that involves an application type problem. Let's say after wildfires destroyed a portion of Glacier National Park, Forest Service biologists needed to determine the germination rate of new seedlings. Using a rope as a radius, they marked off a circular area of the forest within a 40-foot radius and then counted 450 new seedlings in that had germinated in that circle. What was the germination rate in seedlings per acre? Ooh, this is a good one. Okay. Well, let's draw this out. Okay, always do a picture. I always like a picture. So let's do a picture. So I'm going to draw my circle. Okay, so let's say that's the circle. Not bad for a circle. Okay, so what they did was they took a 40-foot rope, right? Let's say they have a stake, and they have a 40-foot rope, and they walked all the way around using the rope, and they mapped out this radius. Okay, so this is a 40-foot radius. Okay, so there's the area we're interested in. Okay, well, first of all, we need, in order to get the germination rate, of per acre, we need to find the area of this thing. Okay? Also understand that acreage is a measurement of area. Okay? Oh. Okay, so let's do that. So all we're going to do is use, since this is radius, right? We're going to use this formula. So area equals pi times 40 squared. Okay? And 40 is 1600 pi, so this is going to be 1600 times pi. And this is in feet squared. So square feet. Okay? Now, the reason why I don't estimate this with using pi is because I don't want any round off error, because we're going to use this number in the next step. So again, don't round, don't estimate until the last step of your calculation, okay? So when you have your final number, that's when you want to round. So I'm going to leave it like this because I want an exact answer for that one. Now, what do we need to do? Well, we need to find the germination rate. Well, what do we know? Okay, so they tell us that what they found was within this circle, they counted 450 new seedlings, right? So all over this area, when they counted the new seedlings, they had 450 new seedlings counted. So we need to find what? Number of seedlings, right? Number of seedlings per area, right? That's what we're looking for. We're trying to find the germination rate of seedlings per area. Okay? So how do we do that? Well, one way to do that is to set up a proportion, right? So why don't we set up a proportion that relates that? So let's say we've got how much do we have? Let's see here. Oops. So we've got 450 new seedlings, right? Over X. Okay, so we got 450 seedlings over X seedlings is equal to, now relate this to the area, right? So this 450 seedlings was found in 1600 pi square feet. We want to find out how many new seedlings there are per acre. So we need to change this from square feet to the number of square feet in an acre, right? Well, how many square feet are there in an acre? There's 43,650, is that right? No, 560. I had it backwards. So 43,560 square feet per acre. This is in square feet, and this is square feet per acre. This is seedlings, right? And this is also seedlings. Okay, so again, make sure you have your proportions set up right? So 450 over X equal to 1600 pi over 43,560 feet per acre. Okay? And so now we solve for x. Okay, now, if I solve for x, I'm going to flip this over, so this would be the same as x over 450 is equal to 43,560 over 1,600 pi. And then I multiply both sides by 450. Okay, and I get x is approximately equal to what? $3,900. Okay, now, but look at this. If you calculate this, look at the units. Okay, so here we've got square feet per acre, right? So let's do the units. So we've got square feet per acre. Okay. Divided by square feet. Times seedlings. Number of seedlings, right? So look here. So we can see that the square feet are going to cancel, and this is seedlings over 1. So guess what? Look what I'm going to get. I'm going to get seedlings per acre. So my units work out. So this is going to be seedlings per acre, which is exactly what I wanted. Okay, and that's the answer. Okay, now, this is not the only way I could have done this. I didn't have to set up a proportion. Now, proportion is easy because once you set up the proportion, then you're good to go. So I set up the proportion of within seedlings to seedlings, right? Because I want to do, we start with seedlings to square feet, and I want to do seedlings per acre. Okay? Now, the other way to do this is just to think about it like this. Well, this is square feet, right? Well, I want to change this into acreage, right? So how do I do that? Well, let's do my conversion, right? So I start with 1,600 pi square feet over 1. And I want to change this into acres. So guess what? I just use my conversion factor and say, well, there are 40, or excuse me, so 1 acre is equal to 43,560 square feet, right? And so square feet cancels with square feet, and I get my acreage is going to be 1,600 pi divided by 43,560, and this is going to be acres. Okay, now, I want the germination rate. So guess what? I'm going to take the number of seedlings that I counted. What was that? The number of seedlings that we counted was 450. So germination rate is number of seedlings per area, just like I said earlier. So this is my area in acres, right? So guess what? I'm going to take the number of seedlings and divide by this number. So I'm going to take 450 seedlings, right? And I'm going to divide by my area, which is this. So it's going to be 1,600 pi over 43,560, right? Now, if I take this number, right, this is a number divided by a fraction, well, what do I get when I simplify this? This is going to equal what? 450 times the the reciprocal of the bottom here, which is going to be 43,560 divided by 1600 pi, and that's going to give you the same number as approximately 3,900 seedlings per acre. That's it. Have a great day.